What's up guys, it's your boy Doing Noel and we are back again. So for today's video guys, we will make a Boolean algebra logic circuit simplification. So let's get it. This is our equipments and materials. 5 volts DC power supply. Our 74LS00 or NAND gate. Our 74LS08 or AND gate, our 74LS32 or OR gate. So 4 pieces LED, 2 pieces SPDT switch, jumper wires, and of course breadboard. So let's start mga buddy. First, let's put our IC. This is our NAND gate. Next, our AND gate. And last is our OR gate. And for our next step, we will put our switch. I'll put it here. And this one is here. So for our next step, based on schematic diagram, our pin number 1 and 2 of our NAND gate is connected to our D1 and D2, which is our switch. So 1 and 2 is connected to each other. So I'll get this and I'll connect it to pin number 1 and 2. And next, based on schematic diagram, pin number 4 and 5 is connected also. And they are connected now. And we will connect it to our switch. So I'll connect it, this one, to the middle pin of our switch, and this one in our D2. So as you can see guys, they're connected now. So for our next step guys, our pin number 3 and 6 of our NAND gate is connected to our OR gate, pin number 1 and 2. So this is our number 3. Connected to pin number 1. Our pin number 6 is connected to pin number 2 of our OR gate, and they are connected now. So for our next step guys, we will move to our AND gate. So this is schematic diagram. Pin number 13 and 12 of AND gate is connected to our switch. So 14, 13, and 12. So this is the number 13. we will connect it to our switch number 1. And our pin number 12, we will connect it to our switch number 2. And they're connected now. So for our next step, our pin number 11 of our AND gate is connected to pin number 13 and 12 of our NAND gate. So first, we will connect the pin number 13 and 12 of our NAND gate. So they're connected now. And then we will put our jumper wire and connect it to our NAND gate, which is pin number 11. They're connected now. So for our next step, we will put now our LED. I guess I'll put it here. This is our in one, probably. And this is our in 2. So based on schematic diagram, our in 1 and in 2 is connected to number 13 and 12 of our AND gate. So I'll get my jumper wires and I'll connect it to number 13, which is here. So I will connect it on positive side of our LED, and pin number 12 is connected to in number 2. So yan. And our in 3 and 4 now we will put our in 4. So I'll put it here. So based on schematic diagram, our in 3 is connected to number 11 of our NAND gate. So 14, 13, 12, 11. So I put it here. And I put it on the positive side. And our in 4 is connected to number 3 of our OR gate. So we connected now. So for our next step, we will connect the switch to positive side of our power supply. So the first pin of our switch is connected to positive side. So and this will connect it on the positive side, and of course the negative side, the third pin. And then for our next step, each of our LED is connected to negative side of our power supply. So this, we'll connect it to this, and this, this, and this also in the top, and this, and this, so ayan guys, na-connect na natin siya. So for our last step, each of our 14 pin of our IC is connected to positive side. So we will start on the NAND gate, number 14, connected to positive side, and then our AND gate is connected to positive side, and then for our last, our OR gate is connected to positive side of our power supply. So that's the last step of our circuit. So let's try and let's see what will be the outcome of our circuit. So we will open the power supply. So as you can see guys, based on the truth table, if D1 and D2 is on low logic, our in 3 and in 4 is on high logic, and our in 2 and in 1 is on low logic. So let's change our D2 to high input. So as you can see guys, our output is on high logic except the in 1. So our in 1 is on low logic. So let's back. So now let's change our D1 to high logic and our D2 to low logic. So as you can see guys, our outputs in 1, in 3 and 4 is on high logic, and our in 2 is on low logic. So let's back. So let's try. Both of our inputs is on high logic. So as you can see guys, our in 1 and in 2 is on high logic, and our in 3 and in 4 is on low logic. So that's our video and circuit for today. I hope you learned something.